All right, so we're going to start with something called a point slope form of a line, okay? All right, so last class we did y equals mx plus b form, which was slope-intercept form. We're going to do another form called point slope form, okay? Okay, so in addition to y equals mx plus b form, we have another form of a line, and it's called point slope form, okay? All right, and it looks like this. So we have y minus y1 is equal to m multiplied by x minus x1, okay? And I have to tell you what these letters mean. So m is the slope, okay? And this coordinate pair x1 comma y1 is a point on the line, okay? It's a point on the line, okay? So that's pretty much it. So we have this line and it passes through the coordinates x1 comma y1 and it has slope m. All right. Okay, so why do we care about this form of the line? Well, this will become apparent in our next example, okay? So let me just write that down. So this form of a line is very useful in the following scenario. Okay. All right, so we're going to start off with an example, okay? So you're going to want to use this form of a line in the following situation, okay? So here's the question. Find the equation of the line with slope m equals 3. No, m equals -3. Sorry, hold on a second. So the slope is -3. Okay. That passes through the point. That passes through the point, let's say 4 comma 8. Okay, and also what will be told to you usually is to put your final answer into y equals mx plus b form, okay? Because we like that form. So also put your final answer in y equals mx plus b form. Okay, also known as slope-intercept form. Okay, so that was from last class. Okay, so how do we do this? It's not that bad. We just need to use this point slope form of a line, okay? That's really all we need to do. So let me just show you guys how to do that. So just use the point slope form with the following info. So with m equals -3 and x1 comma y1 equaling 4 comma 8. Okay, because those are the exact pieces of info that we need for the point slope form. We needed an m, we needed an x1 and a y1. Well, here's all of that information. We have our m and we have our x1 and y1. All right, so I hope that's cool. So now we just have to plug in. So I'm going to write the general form and then I'll plug in. Okay, so it's y minus y1 is equal to m multiplied by x minus x1. Okay, so y stays the same. Our y1 is 8, so I will plug in that for y1. So y minus 8. Our m is -3, and our x1 is 4. Okay, so I hope everyone knows how I went from here to here. I just plugged in, okay? All right, and that's all there is to it. We just need to algebraically manipulate this guy until it's in y equals mx plus b form, okay? All right, so y minus 8, this is equal to, I'm going to distribute the negative 3 into the parentheses, negative 3x plus 12, and now bring the plus 8 to both sides. Plus 8, plus 8, and we get our final answer of y equals negative 3x plus 20. Okay? All right, so any questions at all with how I got this? Okay, yeah, so this is going to be very important in Calculus 1 when you talk about tangent lines. Sometimes you'll want the equation of a tangent line at some specific point to some curve. All right, so this is definitely useful to know. All right, so let's just do another example, okay? Let's do the same thing, but with different equation. All right, so next example, find the equation of the line with slope m equals 4. So with slope 4, that passes through 2, 5. All right, so it's the same deal. So I'm just going to write the general form again. It's y minus y1 is equal to m multiplied by x minus x1. And I'm just going to plug everything in. So y1 in our case is 5. All right, that's our y1 here. So I'll put y minus 5. Our m is 4. So I'm going to plug in 4 for m. And our x1 is 2, okay, which is from right there. All right, and now I just need to put this into, hold on, sorry. Yeah, so now I just need to put this into y equals mx plus b form, okay? So this will be y minus 5. I'm going to distribute the 4. So it'll be 4x minus 8, and then I'll add 5 to both sides. Okay, so final answer is y equals 4x minus 3. All right, so any questions? I think it's pretty straightforward. You just have to use this point slope form of the line, okay? That's all you need to do. Okay, so let's take this a step further in the following way. So sometimes we are just given 2 points on the line, okay? Okay, so in this case, there's just one extra step. You just need to calculate, in this case, calculate the slope using our slope formula. So you do y2 minus y1 divided by x2 minus x1, and then proceed as before. All right, so it's just one extra step. And then proceed as before. Okay, so we find the slope, and then we pick either one of the 2 points that we were given to plug into point slope form. So that's the deal. All right, so what does this look like in practice? So here's an example. So find the equation of the line that passes through the points 3, 4, and 0, negative 3. Okay. Okay, so you can see that this is slightly different than the last example. We're not given a slope here. Okay, so we need to first find the slope, and then we proceed just like before. All right, so that's not too bad. So first find the slope. Okay, so the slope, remember, it's y2 minus y1 is equal divided by x2 minus x1. Okay, so I'll just do yeah, I'll do -3 minus 4. So I'm going to do this guy minus that guy divided by 0 minus 3. Okay. Okay, and that will just come out to -7/3, which is, sorry, -7/-3, which is just +7/3. Okay, so that's our slope. And then now you choose either point. Okay, it does not matter which one you pick. You'll get the same answer. Now choose either point and plug everything in and plug everything in. Into point slope form. Okay, and and the point I will pick, I will use 0, -3. Okay. All right, very good. So remember, it's y minus the y coordinate. So y minus -3 is equal to m. The slope here, it was 7/3, multiplied by x minus the x coordinate. The x coordinate here is 0. So I'm just going to be doing x minus 0 in the parentheses, okay? Okay, so this highlighted portion is just the result of me plugging into point slope form. All right, and now let's just put this into y equals mx plus b form. So the left side will become y plus 3 because of the double negative, and the right side is just 7/3x. And now just subtract 3 from all sides. So y is equal to 7/3 x minus 3. Alrighty. So it was the same thing as before. We just had this extra step of calculating the slope. All right, that was the only difference here. All right. So any questions?
I have a question.
Mm-hmm.
If you were to use the other one, the 4, 3?
3, 4?
3, 4. The 7/3 times 4, what would that come to?
Okay, so let's work it out. So 3, 4. So you would get y minus 4 is equal to 7/3 times x minus
3.
3. Yes. So you're talking about what this would come out to? This,
Yes.
multiplying those two? Yeah, so just the right side would be 7/3 x, and then you just multiply straight across. So you get minus, well, actually, you can just cancel out the 3's like that.
Mm-hmm.
Yeah, so it would just be -7.
Okay.
Yeah.
Thank you.
That's a quicker way to do it. Mm-hmm. But yes, you will get both. You will get the same answer if you use the other point. So there's no worries with that. Okay, so if there are no more questions, I'll move on. So yeah, so just always stop me if anything's unclear. Okay. So the next thing we'll do is parallel and perpendicular lines. Okay. Okay, so we just have some. Okay, so we just have some definitions to go through. Okay. So we just need to define the words parallel and perpendicular. Okay, so we just want to be really explicit here. Okay, so here we go. So 2 lines in the xy plane, so in the Cartesian plane, are parallel. So that's the word we're defining. So I'm going to underline it. Are parallel simply if they do not intersect. If they do not intersect. Okay? So if you have two planes, if you have two lines in the xy plane and they do not intersect, they don't touch each other at all, they are said to be parallel. All right, and here's a key fact about parallel lines. So fact, I'm going to highlight it because it's extremely important. And the fact is, two lines are parallel. Maybe you guys know what I'm about to write. Exactly when they have the same slope. Okay, so that's actually something that you have to prove from the definition of parallel, but we're not going to do that. We'll just take it on faith. So two lines are parallel exactly when they have the same slope. Okay, so if two lines have the same slope, we know for sure that they are parallel. Okay, so we're going to be using that. And we also just need a definition for perpendicular. So just remember DEF means definition. Okay, so let's do perpendicular. So two lines in the XY plane are perpendicular. Okay, and I will underline that word because that's what we're defining here. If they intersect at a 90-degree, or sometimes called a right angle. Okay. Okay, so in the XY plane, what does the picture look like? Well, pretty much, actually, we can just use the axes as an example. The x-axis and the y-axis, they intersect at a 90-degree angle. Okay, so that's an example of perpendicular lines, the x-axis and the y-axis. Okay. Okay, and we have another key fact about perpendicular lines. Okay, so very important, which we'll be using. So two lines are perpendicular exactly when. So we're going to make a statement about their slopes. Exactly when their slopes are negative reciprocals of one another. Okay, so we have another characterization for when two lines are perpendicular, and that's when their slopes are negative reciprocals of one another, all right? So we're going to be using this a lot, and let me just quickly refresh everyone's memory as to what a negative reciprocal is, okay? So recall for a number, call it capital B, doesn't matter. So just for a number capital B, its negative reciprocal is -1 over capital B. Okay, so you flip it and you put a negative sign. That's what a negative reciprocal is. Okay, so just quick example. Can anyone tell me what is the negative reciprocal of 7? So does anyone want to just shout out quickly?
-1 over 7.
Yes. Yeah. So I heard a few people say it and it sounded right. Yeah. So -1 over 7. Good. Okay. How about just a little trickier? How about the negative reciprocal of -3 over 2? What's What is the
Two-thirds?
reciprocal?
2/3.
Yes, 2/3. Perfect. Awesome. It is 2/3. So again, you flip it and you negate it. Since it's negative already, it will become positive. Okay? Excellent, excellent. Okay, good. So we're going to be using these facts a lot. Okay, so let's do an example here. Okay, so the lines y equals -2x plus 6 and y equals -2x minus 4 are parallel because they have the same slope, okay? All right, so they have the same slope of m equaling -2.
And they're both parallel to each other?
Yes, they're parallel to each other, yeah, exactly. All right, and that can be read off immediately because these lines are in y equals mx plus b form. The slope of this first line is -2 because that's the coefficient of x. And in the same way, the slope of this line is also -2 because it's the coefficient of x. All right, and then by our fact earlier, if two lines have the same slope, we know for sure that they are parallel. Okay, good. So now let's do a perpendicular example. So the lines y equals -2x plus 2 and y equals 1/2 x minus 4 are perpendicular. Okay, because -2 and 1/2 are negative reciprocals of one another, okay? Are negative reciprocals of one another. All right, so is everyone cool with why I'm picking the numbers -2 and 1/2? Why are they of importance? Okay, it's because they're the slope of these two lines, respectively.
And the
And-
reciprocals.
Yes. Yes. So first of all, these numbers, -2 and 1/2, are the slopes of these lines. And just like you said, they are negative reciprocals of one another. So their slopes are negative reciprocals of one another, just as I said, and which means the lines are perpendicular. Yes. Alrighty. All right, so let's do a computation. Okay, let's do a computational example. Okay. All right, so let's find the equation of the line parallel to y equals 3x plus 1 that passes through the point 1, 7. Okay. Okay, so there's a few things we need to make note here. We need to figure out what our slope is, and we already have the point that it passes through. So we just need the slope of our desired line. Okay, well, this isn't that bad because the line that we're given, y equals 3x plus 1, has slope 3. Okay, so that's immediately readable from the equation because it's in y equals mx plus b form. Okay, so the line y equals 3x plus 1 has slope 3. Thus, our desired line, so the line that we're looking for, will also have slope 3. Will also have slope 3. Okay, and why is that? Because we're looking for a line parallel to this line. Okay, and if a line is parallel to y equals 3x plus 1, it will have slope 3. Okay, it will have the same slope. Okay, There we go. So now we have all of our data, all of our info we need. So now it's just like before. So now we use point slope form. We use point slope form with the following plugins, with m equals 3 and x1, y1 equaling 1, 7. Okay, so now we have reduced the question just like the previous example. Okay. Okay, so I'm just gonna do this computation. So remember, it's y minus whatever the y coordinate is. In this case, it's 7. This will be y minus 7 is equal to the slope m. So that's 3, and then x minus the x coordinate, which is 1. All right. So I just plugged in to point slope form, and now let me just do some algebra to put this guy into y equals mx plus b form. Okay, so let me distribute the 3. So it'd be 3x minus 3. Now add 7 to both sides. So your final answer is y is equal to 3x plus 4. Yes. Okay. So just make note that this line is definitely parallel to the line that we were given because they both have a slope of 3. Okay, so this is the correct line. Okay, good. Let's do the same thing, but now let's do it in the perpendicular case. Okay, so next, find the equation of the line perpendicular, okay, perpendicular to y equals 3x plus 3, that passes through, what point are we doing? 3, 0. Okay, so we're looking for a line that's perpendicular to y equals 3x plus 3. So what slope will our line that we want to find have? So our desired line, so I'm going to let someone answer this in a second. So our desired line, so the line that we're looking for, will have slope m equals what? Okay, so we're looking for a line that's perpendicular to 3x plus 3. So what does that mean about the slope of our desired line? So does someone want to answer this?
Negative.
Okay, I heard like 3 people say it, but I think I heard -1/3.
Yeah.
Okay. Yes, so that is exactly correct. So yeah, so listen, our given line has slope 3. We want something that's perpendicular to that, so we ought to take the negative reciprocal of 3, and that's -1/3. Okay, and now we are in exactly the same case as those first few examples from class. You just use point slope form. Okay, so now use, just like before, point slope form. Okay, so remember, it's y minus the y coordinate. Well, the y coordinate's 0, so it's going to be y minus 0. Then you put the slope in, that's m. Open up your parentheses, and you do x minus the x coordinate, and that's 3. All right, and yeah, there's actually not much to do here. So the left side is just y, since subtracting 0 doesn't do anything. And then the right side, you can just distribute the -1/3 in, and you'll get -1/3 x plus 1. Okay. All right, so is everyone clear on that? So I distributed -1/3 into those parentheses, and you get -1/3 x plus 1 after doing so.
Can you just elaborate on the last step of factoring, the last part? So -1/3 times -3.
Yeah, exactly. So yeah, so you're just looking at, okay, yeah, so the right side, negative 1/3 times x minus 3. So I'm just going to distribute this into both terms. So that's negative 1/3 x. And then, so I have negative 1 times negative 3 over 3. So here's the negative 1/3, and I'm multiplying it by negative 3. Okay. And then you can just cancel out the 3 with that 3, and you're just left with negative 1 times negative 1. So it's negative 1/3 x plus 1.
So essentially, could it just be, it would be 3 over,
3.
yeah.
Yes. Yeah, that's another way to, exactly, that's another way to think about it. It would just be 3 over 3, which is 1.
Got it. Thank you.
Of course. All right, good, good. So let's, what else are we doing? Yeah, all right, so let's do a slightly different example, but it's still in the same topic. So this will be something you'll see on the homework as well. So, so determine whether the lines 4x minus 7y equals 10 and 7x plus 4y equals 1. Okay, so these are two equations of lines. So let's determine whether they are parallel, perpendicular, or neither. Okay, so it's your job to see, are these two lines parallel, perpendicular, or neither? Okay, they have to be exactly one. Okay, you can't be both parallel and perpendicular at the same time. Okay, so all that needs to be done, we need to find the slopes, and the best way to do that is to put them into y equals mx plus b form. Okay, so we need to put both lines into y equals mx plus b form to easily read off the slope. That's the whole point. It's just so we can quickly get the slope. Okay. All right. So let's do that. That's really not that bad. Okay. So the first one is 4x minus 7y equals 10. So we can subtract 4x from both sides. So this will be negative 7y is equal to negative 4x plus 10. And now divide all sides by negative 7. So you'll get y is equal to 4 over 7x minus 10 over 7. Okay, so that's the first guy. So that's in y equals mx plus b form right now.
The 4 over 7 not be negative?
It is not going to be negative because I'm doing negative 4 divided by negative 7. Yeah, so double negative is always a positive. Okay, so that's the first guy. And how about the second one? Let's put 7x plus 4y equals 1 into y equals mx plus b form. Okay, so this will be 4y is equal to negative 7x plus 1. And now divide all sides by 4. You will get negative 7 over 4x plus 1/4. Okay, so I'm just doing some algebra. Those steps. Okay, so that's good. So the two slopes are now easily readable. So the two slopes are what? Okay, the two slopes are, well, remember, the slope is just the coefficient in front of x. So it is, there are 4 over 7 and negative 7/4. Okay, and you can quickly see that these are negative reciprocals of one another, okay? These are negative reciprocals of each other, okay? So the lines are perpendicular. That was our key fact from earlier. So the lines are perpendicular. Okay. So being parallel or perpendicular is very closely connected to slopes. Okay, so we always want to think about slopes whenever we're given a question like this. Right. All right. So any questions about this example? All right. So the conclusion was that the lines are perpendicular. Okay. All right. And of course, doing this in a homework problem, you would need to show all of this work, okay? You can't just put the word perpendicular because that doesn't show me that you know what's going on, okay? All right. Okay, so next thing we will do, we'll do horizontal and vertical lines, okay? All right, so we're moving along. Horizontal and vertical lines. All right, good. So let's just get some definitions going. Okay, so definition: a horizontal line is a line y equals mx plus b with slope m equaling 0. Okay, so it's a special line such that the slope of it is 0. Okay, so thus a horizontal line takes the form. Sorry. Okay, so thus a horizontal line takes the form y equals b. Okay, and why is that? Well, that's just because if m is 0, then this term vanishes, okay? There's no x term because m is 0. So that goes away, and you're just left with y equals b, okay? Okay, and just very quick example. Y equals 1 has a graph. So the graph of this, so this is just a horizontal line that passes through the point 0, comma 1. Okay. Okay, so it just looks like that.
Will it take any coordinates, or that's not really anything I mean?
What do you mean by take any coordinates? Like, does it have coordinates? Like, what do you
Yeah.
mean? Yeah, so any line, I mean, here's a point on the line, and there's definitely a coordinate associated to that point. So yeah, it's going to pass through. But every single y coordinate of this guy will be 1.
Okay.
Okay, like this point right here will look like a comma 1 for some x coordinate a, something, yeah. Okay, so let's talk about vertical lines, okay? Very quickly. A vertical line is defined okay, a vertical line is defined by the equation x equals a. Okay, so it's not in y equals form, it's actually in x equals form. And its slope is undefined. Okay, and so let's just look at it at an example. Let's look at x equals 2. All right, this is just going to be a vertical line that passes through the point 2 on the x-axis. Okay, so there's 2, and now just put a vertical line there. Okay, And I leave it to you guys to think about why the slope is undefined. Okay, so that will be a question on homework 3. It's a nice thing to think about. So just a hint for that. So a hint for why the slope is undefined. Try using the slope formula. Okay. All right. So just think about that, and let's just So I don't want anyone to shout it out now, just because it's a homework question. But just try using the slope formula applied to a vertical line, and you'll see that something weird happens. Okay.
For a horizontal line, does it have undefined slope or no?
Nope. So I wrote in the definition of a horizontal line, it has slope 0.
Okay.
Yeah, which you can check by using the slope formula. Yeah. All right. So that'll be a question on the homework. All right, so what else? What else? All right. So that's it for horizontal and vertical. Now let's talk about interval notation. Okay. Okay, so just a quick introduction. So we will now introduce something handy called interval notation. Okay, to denote certain sets of numbers. Okay, that's its use. To denote certain sets of numbers. Okay, so it's just a very handy and compact way to notate sets of numbers. Okay, it'll just it's just a it's just a good thing. All right, so just in what follows. So in the following setup, let A and B be two distinct real numbers. Okay, be two distinct real numbers. And let's just assume that A is less than B. Okay. All right, so that's the setup, and here we go. So here's the definition. All right, so we denote by parentheses A comma B the set. Okay, hold on. The set of all real numbers between A and B, but not including A and B, okay? But not including A and B. Okay, so we're not including those endpoints, but this notation here, these symbols, A comma B with parentheses, that will mean all numbers between A and B. Okay, so it does look very similar to our coordinate pair, our XY coordinate pair, but its meaning will be obvious upon context. Okay, in the context of the situation, you'll know whether this means a coordinate pair or if it means interval notation. Okay. All right, and just some terminology. We call A comma B an open interval.
Why do we not include A and B endpoints?
So there's no reason why. This is just a way to notate all the numbers between A and B, but not including them. And now I will introduce a way to include A and B.
Oh, okay.
Yeah, like it just depends on the situation whether we want to include the endpoints or not.
Okay.
All right, so let's get to that now. So we denote, so another definition, we denote by bracket A, comma B bracket, the same as before, but with a key difference. the same as before, except this set includes both A and B, okay? So we're including the endpoints now. Okay, so the difference here is that we have brackets, and the brackets mean that we're actually including those points A and B in our set. Before, they were not included, but now in this notation they are. All right, and what is the terminology? We call this guy bracket AB a closed interval. Okay, and the reasoning for this terminology, why it's open and closed, that's something that's discussed in an upper level math class. Okay, but just for now, let's just take those as the terminology.
So it just has to do with whether you accept the endpoints or not.
Yes, exactly. So an open interval will not accept the endpoints. Closed interval will. But we also have these half open intervals. So that will come next. So this is the last one. Similarly, so I think you guys can probably guess what half open will mean. We have the half open intervals. Okay, and these are one of two things. It's bracket A, B parenthesis, and parentheses A, and then B bracket. Okay, and these which include A and B respectively. Okay. All right, so let's just talk about this definition quickly. So the first one, bracket A, B parenthesis, that includes A, but does not include B, okay? The second one, parentheses A, B bracket, that includes B, but does not include A. So pretty much wherever the bracket is around, you include that number in the set. If there's a parenthesis, you do not include that number in the set.
But all of the other numbers between the two are still included.
Yes.
Okay.
So we're going to show these visually on a number line next. So that'll help visualize these things. And just one more note is that we do allow infinity in this setup. Okay, so note and or B, so those numbers can be plus or minus infinity.
When we use plus or minus infinity, it will always be in parentheses, right? Because it's always going to be like open.
Yeah, exactly. Whenever there's infinity involved, you will always have a parenthesis next to it.
Okay.
Because you can't, infinity is not a number, really. It's more of an idea.
Yeah.
Good. Okay, so that's the setup. I know that's a lot of writing. But now we can look at some examples, okay? So that's nice. So how about this guy? The open interval. How about parentheses 3 comma 4 parentheses? Okay, so I know this looks very similar to the coordinate pair 3, 4, but since I have the word open interval before it, by context, it should be clear that I'm not talking about the XY coordinate pair. Okay, so let's just look at this on a number line. Okay, so here's the real number line. I'll put 3 here. I'll put 4 here. I'll put an open bubble at 3. And I'll also put an open bubble at 4. All right, so it's just all these numbers between 3 and 4, but not including 3 and 4. That's why I have open bubbles on 3 and 4. Okay. Okay, let's do another one.
When you say infinity is much more of an idea than a number, what do you mean? What do you imply by that? I mean,
Um,
I mean,
well,
I mean, yeah.
yeah, no, that's a great question. It's kind of off topic, and it's
Yeah,
hard.
I'm sorry about that. If it's a
No, no,
little.
that's fine. That's a great question. Just pretty much, we can't treat infinity like a number, like 3 or 4. It behaves quite differently than actual numbers like 3 and 4. So it's used in calculus a lot to express that a number grows without any bound. So if a number gets arbitrarily large, it gets as large as we want it to, then we kind of say that that number tends to infinity.
Okay.
Yeah, that's just a quick explanation. But the short version is that we can't treat infinity like a number.
Okay.
All right, and speaking of infinity, let's do an example with that. So let's do -1 comma infinity. All right, so what's this going to look like on the number line? All right, so again, let me just draw the real number line. I'll put down -1 here. So we have a parenthesis next to -1. That means we're not including it in our set. So I will put an open bubble above it, open circle. Okay, but we're now going all the way to infinity, so this line will just extend infinitely long. Okay. So you can just imagine this right arrow, it's going on to the right forever. Okay, so we're talking about all real numbers greater than -1 here. Right. Okay, how about this? How about the half open 4 comma 5? Okay, so it's the same setup as before. I'll put 4 here. I'll put 5 here. So there is a parenthesis at 4. So I'm going to put an open bubble or open circle there. But we have a bracket next to 5. So I'll put a closed in circle there. All right, and then just connect. Okay. So that's pretty much it. So what's going on here is that we're including 5 in our set, which is why I have a closed bubble. All right. And one last example. How about this? Let's look at parentheses -infinity, comma -1 bracket. What will that look like on the number line? Okay, so let me just draw the number line again. I'll put -1 really anywhere I want. Okay, so -1 has a bracket, which means we're including it in our set. So I should put a closed circle or closed bubble above it. And now we want to go off to -infinity. So I'll put just a line that's extending to the left, like that. All right, so I drew that kind of badly. Hold on. Okay, so it's all real numbers less than or equal to -1. All right, so that's that. So we also just want to introduce one other thing called the union symbol, okay? So we can also use the union symbol, which is pretty much just looks like a U, to denote all real numbers less than A, or greater than B.
What is meant by denote? Like, I mean, like to connect?
So that's what this symbol means.
Okay.
So it's like I'm attaching a definition to this symbol.
Okay.
Yeah, that's what denote means. To denote all real numbers less than A or greater than B as, so what does this look like? So it would just look like -infinity, comma A. Okay, that's the first part. That's all real numbers less than A. And now I use the union symbol for or. So there's my union symbol. And now the last thing to do is put greater than B. And to do that, well, you just put parentheses B, comma, infinity. Okay, so the union symbol is useful for when our intervals here aren't connected. If we want to put like two disjointed intervals. Okay, so let's just do a quick example. Use interval notation to express all real numbers less than or equal to -1 or greater than 1. Okay, so how can we express this set of numbers in interval notation? Okay, so let's just take it one piece at a time. So first of all, we want all real numbers less than or equal to -1. How do we deal with that? Well, that will just be -infinity, comma, -1, but we have less than or equal to, which means we're going to include -1 in our set. So I will put a bracket there.
So for unions, you can also include it for equal to?
Yes. So I didn't write that up here. I just wrote less than or greater than. But yeah, you can also do two as well. Absolutely. Good, so that's the first piece. And now I translate this or directly to a union symbol. So that's that. And now I will do greater than 1, which means we're not including 1. So I'll put a parenthesis, and greater than 1 is just 1 to infinity.
If you had and, would you still translate that to union?
No, so that would be so we're not going to do that, but that would be this symbol, and that means intersection.
Oh, okay, that's opposite then.
But we're not going to be using that, so don't worry. But yeah, and would translate into the intersection.
Hmm.
All right, good. So that is just a crash course on interval notation. It's very useful. And now let's actually use it in practice. Okay, why do we so much?
Wait, quick question. If you want to like backwards, I don't even know if you use this, but like if you have it written in interval notation and then you have to express it like in words for some reason, like as an answer, would it also be okay? Oh, wait. It was a crazy question. Forget about it. Sorry.
Yeah, so I'm going to tell you in the question prompt to express your answer using interval notation, if that's what you were.
No, I was confused about the or an end you just answered, and I was just like still on that mindset. Sorry.
Okay, gotcha. Yeah, so or translates directly to that union symbol, and the end we won't use, but that will translate to this intersection symbol. Okay, so this is a topic in math called set theory. Okay, but we will not go into that. Okay, so this is set theory stuff.
What would an and problem look like?
We're not going to be doing and,
Oh.
but it would pretty much, if you have like two overlapping intervals, let's say you have this interval here and then this one here, the end would be the intersection. It would be just what's between both.
All right.
Oh, wait. So back a little bit. Sorry. If you like what I was gonna ask before, I think now it makes sense. Like finally, if I wanted to express like from the notation to words, could I say like negative infinity to infinity, but -1 to 1?
Oh, yeah, that would work too. But that usually looks like this in set theory. You put -infinity to infinity, and then you put this slash, which is like a set minus, and you would subtract out -1 to 1. So that's
okay.
Yeah, so that's a more advanced notation that you're not really going to run into here, but you'll see it if you ever go into a class that goes into set theory, as I wrote up here.
Okay. Thank you.
No, I would prefer to not use this notation just because it's kind of confusing.
Yeah, it is.
So, yeah, but these are all great questions, though. So, if you study math more so, and you take some more advanced classes, you will definitely run into this more. All right, very cool. All right, so now let's actually use this interval notation in practice. So we're going to use it when we solve linear inequalities. Okay. Okay, so let me just do a little introduction here, okay? Sorry. So an example of a linear inequality is simply x, we'll do x minus 15 is less than 4. Okay, that's an example of a linear inequality. And the goal is we'd like to solve for which x values satisfy this inequality. Okay, so we're just going to figure out how to do this. And luckily, the process is almost identical to solving linear equations, but there's one key difference. So let me just write that and then I'll explain. So the process is almost identical to solving linear equations. Okay, however, here's the key difference. One key difference is that you must flip the inequality symbol the other way. Sorry, it's a lot of writing. When multiplying or dividing both sides by a negative number. Okay, so that's the key difference that we need to be careful with. So let me just highlight that. Okay, so let's actually solve some of these guys, okay? So we're gonna solve these and we're gonna express our solutions in interval notation. All right, so let's use that. So let's solve 3x minus 2 is less than 1. Okay, so the process is the same as solving linear equations, except so you just want to isolate x. All right, you want to essentially solve for x in this thing. So let's just get x by itself. So let's add 2 to both sides. How about that? So then that would give us 3x is less than 3. And now I can divide all sides by 3, which would give me x is less than 1. Okay, so that is the answer, and I would like for you to express this solution in interval notation. All right, so the answer is all x values, all numbers, strictly less than 1. So that will look like this, negative infinity, comma 1. Okay, so this is the solution set. Okay, and
That would be negative infinity.
It's negative infinity because I'm talking about all numbers less than 1.
Oh, okay, got it.
And the fact that I have a parenthesis here is precisely because it's less than 1 and not less than or equal to 1. Okay, so I'm not including the number 1 in my solution set. Okay, very good. So how about this example? Okay, so we'll get some nice practice using our interval notation as well. So how about this? Let's solve 6 is greater than or equal to x minus 1. X minus 1. Okay, not bad. So the same thing, we want to isolate x. So how about we add 1 to all sides? So we'll get that x, yeah, so we'll get that 7 is greater than or equal to x. Okay. All right, so now let's notate this into interval notation. So we want all x values that are less than or equal to 7. Okay, so that's going to look like this. Negative infinity to 7, but I will put a closed bracket there. Okay, so that's the solution set.
Wouldn't the numbers be flipped? It would be 7, 7 and infinity because greater than or equal to 7.
Yeah, so I see. So when you do the interval notation, you always put the smaller value first.
Okay.
You do smaller number, comma, bigger number. But I see what you're saying because this inequality can be, it's the same thing as x is less than or equal to 7. Just by reading it in the other direction. So now maybe it's a little more clear how you get that.
Got it. Thank you.
All right, good. So just, I think the most important point here is that I have a closed bracket here, which means I'm including 7, and that's because I have a greater than or equal sign. Okay, I'm including 7 in my solution set. So I will put a closed bracket. Okay, let's do one where we have to flip the inequality. Okay, how about this? Negative 2x minus 1 is greater than or equal to 5. Okay, so let me add 1 to both sides. So I'll get that negative 2x is greater than or equal to 6. Now divide all sides by negative 2. That will get me x is less than or equal to negative 3. Okay, so look, I flipped the inequality here. Okay, why did I do so? Because I divided both sides by a negative number. All right, I divided both sides by negative 2. Okay, and then let's just put this into interval notation. I'm looking at all numbers that are less than or equal to negative 3. So this will be negative infinity to negative 3, and I will include negative 3 in my solution. So I'm going to put a closed bracket. Okay, so that's the solution set. Okay, so on the homeworks and exams, I'm just going to say express your solution using interval notation, and so that just means I want you to write this.
And these are the values that can be plugged into X, to fill it.
Exactly. Yep. Everything in this interval can be plugged into X, and they will solve the inequality. Absolutely.
What happens if you have like 2 closed brackets? Would the equation look different if you have like 2 closed brackets?
Yeah, so that's coming next.
Oh.
Yeah, so that, yeah, so we will get to that. So does anyone, just before I move on, does anyone have any questions? Okay, so what Laura just alluded to, that will come into play in something called compound inequalities, okay? Okay, so let's just get a definition for this. Okay, so what is a compound inequality? A compound. Okay, so a compound inequality is two inequalities in one statement, okay? Okay. And what's an example of such? How about 4 is less than 2x plus 1 is less than or equal to 6? Okay, so we have two inequalities, but written as kind of one mathematical statement, okay? So this is a compound inequality, okay? Okay, so we can solve these in one of two ways, okay? So let me just write that. We can solve these in one of two ways. So the first way, by separating them into two inequalities. So separate them into two separate inequalities and solve. Or second way, by performing algebraic manipulations to all three sides simultaneously. So all three sides simultaneously. Okay. All right, so we're gonna use both of these methods, and you can do whichever one you're more comfortable with. Okay, so what's the example? Yeah, so we're gonna do both methods here. So let's solve 3 is less than or equal to 2x plus 2 is less than 6. Okay, and express your answer in interval notation, okay? Okay, so method 1 was to separate this into two separate inequalities and solve them separately. Okay, so you separate as such. Separate into, so first you take the first piece, 3 is less than or equal to 2x plus 2. 3 is less than or equal to 2x plus 2. And the second piece, 2x plus 2 is less than 6. Okay, and we just solve both of these. Okay, so how do we do this? So let me start with the one on the left first. If I subtract 2 on both sides, I'll get 1 is less than or equal to 2x. Divide both sides by 2, I'll get that 1/2 is less than or equal to x. That's the left one. And how about the right one? So this will be 2x is less than 4. And divide both sides by 2, x is less than 2. All right, so I just solved both of those inequalities really quickly. So here's our solution. So our solution set is going to be both of these inequalities put together, okay? So our solution is 1/2 is less than or equal to x is less than 2, okay? And how do we put this in interval notation? Which is, okay, so we have a less than or equal sign attached to the 1/2. So I will put a bracket next to that. but I just have a less than sign with the 2, which means I'm not including 2 in my solution set, so I should put a parenthesis around that one. Okay, so which is that in interval notation?
So we should always be able to get like an X in the middle, or
Yes.
like something the same for both sides, always.
Yeah, you're going to get an X in the middle, exactly. So actually here, I know I said we weren't going to be using intersection or the word end, but really what you're doing here is you're taking the intersection of these two intervals, okay? But you don't need to think of it like that if you don't want to, okay? All right, so here's your answer. So let me just say it again. We're including 1/2 in our solution set because there's a less than or equal sign, so I have the brackets, but we're not including 2, so I put parentheses. All right, all right, let's, okay, so now let's use method 2, okay? Okay, method 2. So method 2 was just to perform all of your algebraic manipulations to all 3 sides simultaneously. So this will be 3 is less than or equal to 2x plus 2 is less than 6. Okay, and the goal is to get an x in the middle, okay, as Faye just said. All right, so if I want to get an x in the middle, I should subtract 2 from all 3 sides. Okay, so let me do that. All right, so the left side is just 1, the middle is 2x, and the right side is 3. Okay, and now to isolate x, I need to divide all 3 sides by 2. So now divide all 3 sides by 2. All right, so I kind of like this method a little better because I feel like it's shorter. So yeah, so you get 1/2 is less than x, less than or equal to x is less than or equal to, oh, sorry. So this should be 4 on the right side. All right. Yeah, so 1/2 is less than or equal to x, which is less than or equal to 2. All right, and this is the same answer as method 1. All right, hold on, let's have a mistake in my notes here. Just give me a second. Okay, let's do one more that's a little more involved. Okay, so let's solve 5x minus 10 is less than 7x minus 2 is less than 3 plus x. Okay. Okay, so when there are variables on all 3 sides like this, you're going to want to use method 2, okay, which is solving it simultaneously. Method 1 is going to be kind of messy, so let me just write that quickly. So when there are variables, so x's, when I say variables, I mean when there are x's on all 3 sides, like above, there are variables on all 3 sides, like in this example. It is best, oh, sorry, it is best to use method 1. I think I said method 2. I meant to say method 1. It is best to use method 1, okay? Yes. Okay, so that was when you split it up into 2 separate inequalities and solved. Okay, so first we solve this guy. 5x minus 10 is less than 7x minus 2. So you do 5x minus 10 is less than 7x minus 2. And the second one that we solve is 7x minus 2 is less than 3 plus x. 7x minus 2 is less than 3 plus x. Okay, so we just need to solve both of these inequalities, and that's it. Okay, so on this, so I'll start with the left one. So let me subtract 7x from both sides here. So I'll get that negative 2x minus 10 is less than negative 2. Now let me add 10 to both sides. I'll get that negative 2x is less than 8. Okay, now I need to divide both sides by negative 2, which means I need to flip the inequality sign, okay? So this will be turned into x is greater than 4. Okay, so I hope that's okay. I divided both sides by negative 2, so I need to change it from a less than sign to a greater than sign, okay?
I have a question.
Yeah, sure.
How do you know, like, when subtracting the x's, which side to start first? Like, how to determine which would be left or right?
Yes, it does not matter. I could have subtracted 5x from both sides if I wanted to start it off. Yeah, it doesn't matter. I just, in general, I like to keep my x's on the left side and my numbers on the right side.
Thank you.
But no, it would have been fine. Yeah, no problem. So that's our first one. We solved the first guy. Now we just need to solve the second one, okay? Okay, so let me subtract x from both sides. So I'll get that 6x minus 2 is less than 3. I'll add 2 to both sides. So I'll get 6x is less than 5. And now divide both sides by 6. I'll get that x is less than 5 over 6. Okay, so that's our solution set. And now let's just write this out quickly. So our solution, we need to put all of this together. X is greater than 4, but it's also less than 5/6, okay? Oh, okay, so you guys should correct me if you see a mistake. This should be x is greater than negative 4, okay? So the left inequality should be x is greater than negative 4, okay? Okay, so now we're looking for x is greater than negative 4, but also less than 5/6. So it's going to be negative 4 less than x less than 5 over 6. Okay, so we're not including the points negative 4 and 5 over 6, so we'll use parentheses in our interval notation. So negative 4 comma 5 over 6. All right, so any questions? All right. All right, so we're going to do our last thing of the night, solving absolute value inequalities, okay? Okay, so we need to talk about what an absolute value is first. So this will come in the form of a definition, okay? All right, so the absolute value of a number, and we denote it by a bar, 2 bars with an x in the middle, denoted by the absolute value of x. It has multiple definitions, but the one we'll go with for tonight is can be defined as its distance away from 0. Okay. So how far is our number away from 0 on the number line? All right, so here's an example quickly. The absolute value of 3 is 3. The absolute value of -7 is +7. The absolute value of -18, the absolute value of -18 is +18. Okay, so the absolute value will always return a positive number, okay? You'll never get a negative from this guy. Okay, so very quickly, let's just talk about a quick fact regarding absolute values. So let A be a real number, okay? Just any old number. Then the expression, so this is a very important expression, absolute value of x minus capital A. Okay, what does this mean? This actually has a nice interpretation. It represents the distance. So it's the distance from x to this number capital A. Okay, so we can actually quickly measure how far two numbers are from each other just by considering the absolute value of their difference. Okay, so this is kind of cool. All right, so let's look at an example. So the expression absolute value of x minus 3 represents some distance. It represents the distance. Okay, so that's how you should think of this as. It represents the distance from x to 3, +3. Okay, and x here is any number of our choosing. So let's actually plug in something here. All right, so if we let x equal 2, we would expect, well, we would expect the distance from 2 to 3 to be 1, right? Because on the number line, 2 and 3 are 1 unit away from each other, okay? So we would expect the distance from 2 to 3 to be 1, right? Because they're literally 1 unit apart on the number line. And this works actually because the absolute value of x minus 3, let me plug in 2, I'll get 2 minus 3. Absolute value is -1, so 2 minus 3 is -1. The absolute value of -1 is +1. So we get what we expected, okay? We in fact do get that the distance from 2 to 3 is 1. All right, so the absolute value allows us to quickly measure distances between numbers. Okay. All right, so now let's take in inequality here. So how about this? The absolute value of x minus 5 less than 4. What does this represent? Okay, so first of all, the left side represents the distance between x and 5. But the less than 4 means we're looking at all numbers that are less than a distance of 4 from the number 5, okay? So this represents x values that are less than a distance of 4 from the number 5. Okay, so that's what this inequality represents visually. Okay, it's all x values that are less than a distance of 4 from the number 5. All right, I'm running out of time, so
I have a quick question.
Mhm.
If you want to move things around, like if I want to like move the -5, like put +5 on both sides, would the mark of the absolute value also move around, or would it like, what would happen to it?
So you cannot at this stage, like as it's written here, you cannot just add 5 to both sides since there's an absolute
Okay.
on the left side.
Okay.
Yeah, so we're gonna have to transform this into a compound inequality, and then we can add 5 to all sides. Which
Okay.
get to just right now. But yeah, so you cannot just add
Thank you.
both sides. Yeah. Okay, so let's just get right to it. So definition: a linear absolute value inequality are inequalities of the form. So they come in two flavors, okay? Of the form. One, absolute value of ax plus b is less than k, or the absolute value of ax plus b is greater than k. Okay, so here x is a variable, and a, b, and k are numbers. Okay, and we can have less than or equal signs or greater than or equal signs with these two. Okay, so there can be a line underneath all of these. Okay. All right, so we need to figure out how to solve these. So quickly, just an example. The example from before, x minus 5, absolute value less than 4, is an absolute value inequality. Okay, so it's of the type 1 up here. Okay, so here we go. Here are our key facts. So we want to figure out how to solve these guys. Well, this is how. So 1, the absolute value of ax plus b less than k is equivalent. See if I can. Hold on, sorry. Okay. Is equivalent to the compound inequality negative k less than ax plus b less than positive k. Okay, so to solve an inequality of this form, you just need to solve this compound inequality. Okay, they are equivalent. Okay, how about for the second type? Ax plus b in absolute value greater than k is equivalent. This is equivalent to ax plus b is less than negative k, or ax plus b greater than k. Okay, so again, you need to solve two inequalities. So if you're in this situation, you have to solve this and solve that guy. All right, so let's use this fact and to solve something, and then we'll be done for the night, all right? I'll try and finish on time. Okay, so first example. Let's solve absolute value of x minus 1 is less than or equal to 3. Okay, so so we're going to want to use this previous fact up here, okay? So by the previous fact, this is equivalent to the compound inequality. Okay, so we just use this fact. It's you take the number on the right side, make it negative and positive. So you rewrite it like this. Negative 3 is less than or equal to x minus 1 is less than or equal to positive 3. All right, so I'm literally just using this fact 1 here and rewriting it as so. And luckily, we know how to solve compound inequalities. So this is now an easy thing. So I'm going to just add 1 to all sides. So what will that give me? That'll give me negative 2 is less than or equal to x is less than or equal to 4. And that's actually the answer. Okay. And we want to put this in interval notation, so which is negative 2 comma 4 with brackets in interval notation. Okay? And I'm using brackets because both inequalities are less than or equals. All right, so we're including the endpoints in our set. All right, good. Let's do one final one of type 2, and we'll be done. Okay, so last thing of the night. Solve absolute value of x minus 4 is greater than or equal to 7. Okay, so we just need to go back up to fact 2 and rewrite it into both of these inequalities. Okay, so you write it less than or equal to negative k and greater than or equal to k. So let's do that. So this is, so by the fact, this is the same as the following. So you do x minus 4 is less than or equal to negative 7, or x minus 4 is greater than or equal to positive 7. All right, so to see how I got this, you just need to look up at the fact here, okay? You just rewrite it using these two highlighted portions. Good, and now we just have to solve both of these inequalities. So let me add 4 to both sides. This will give me x is less than or equal to 3, or add 4 to all sides, x is greater than or equal to 11.
The or in this statement means what? That you're just connecting
Yes,
both of them?
so if you recall from earlier, we used the union symbol for or.
Okay.
That's exactly what we're going to do. So x less than or equal to 3, that can be notated as negative infinity to 3 with a closed bracket. So that's that guy. The or I will write directly as a union symbol. And the final piece can be written as 11 comma infinity. That's that guy. All right, so I hope everyone sees the translation from here to here. I'm just translating everything into interval notation. All right, so that's all I have. I'll stick around after class as usual. Homework is due tonight, and I'll see you guys on Thursday. Okay, thank you.
Thank you.
Thank you.
Thank you, Professor.
Real quick, I think the last one you meant to put x is less than or equal to minus 3 because minus 7 plus 4 would be minus 3.
Yeah.
Yes, definitely. Thank you.
I was checking the same thing.
Yeah, perfect. Thank you, guys. Yeah.
Thank you.